Hello everyone, this is Group 15 presenting their information visualization task. This video demonstrates 3 interactive crime data visualization systems built on the Los Angeles crime incidents dataset, covering reported crimes from 2020 to 2024. Each system shares the same analytical goals but takes a different design approach. Together, they form a unified platform for exploring crime patterns, trends, and victim demographics. System A is the foundation. Starting with the spatial density heat map, this shows crime incidents across Los Angeles where grid cells are colored using the Viridis scale. Here, darker purple means more incidents and brighter yellow means fewer. This binned approach avoids overplotting and makes hotspots immediately visible. You can already see that crime concentrates heavily in the central and eastern parts of the city. Moving to the crime categories bar chart, crime descriptions have been grouped into broader categories such as violent crime, property crime, and vehicle crime. This aggregation was a deliberate design decision to reduce cognitive load. Showing dozens of individual crime types at once would make the chart unreadable. Now, looking at the temporal line chart on the right, daily data was too noisy, so incidents were aggregated to monthly resolution, which smooths out short-term fluctuations and reveals longer-term trends more clearly. Finally, the victim sex and victim age charts at the bottom, these show the demographic breakdown of the victim across the dataset. The interaction model follows Schneiderman's information-seeking rule. Overview first, zoom and filter, then detail on demand. You can click a crime category bar to filter the whole dashboard, drag across the map to brush a region, or click bars in the victim sex and age charts to highlight subsets. All 5 views are coordinated. Any selection propagates across everything simultaneously. System B takes a more incident-level approach, starting with the map. Rather than aggregating data into bins, every crime is plotted as an individual point at its exact GPS coordinates. This preserves precise location information and lets user engage directly with specific incidents. Clicking a single point selects that one crime, the details ripple across all other views. Looking at the temporal heat map, rather than a line chart, time is represented as a year-by-month grid, which makes seasonal patterns easy to spot but trades off some ability to track long-term trends. Now the crime type dot plot. This ranks the top crime descriptions by frequency, preserving granular detail rather than grouping into broader categories. Looking at the victim sex and age charts, these update dynamically based on whatever selection is active across the dashboard. The key feature of System B is generalized selection. Once you have clicked an incident on the map, the Generalize button becomes available. Pressing it looks up which division that incident belongs to and expands the entire dashboard to show all crimes across that area. The map dots for the whole division turn gold, and every other chart updates accordingly. We can move from one data point to an entire neighborhood in a single click. You can also drag a brush rectangle on the map to select multiple incidents from a region at once and compare that subset against the full dataset through the coordinated views. Lastly, System C makes a more structured, control-driven approach. Starting with the filtering controls at the top, year range, area, and crime group, these let users explicitly define what subset of data they want to examine before they even look at the charts. This reduces ambiguity about what's being shown at any given point. Looking at the temporal chart, this combines a primary area chart with a smaller overview chart underneath, letting you drag to zoom into a specific time window while keeping the full timeline visible for context. Now the crime type ranking bar chart, this shows the top crime descriptions by frequency. Clicking a bar highlights that crime type and filters the rest of the dashboard accordingly. Moving to the scatter map, each dot represents an individual crime incident at its GPS location. The age band by crime group heat map, this is a grid where rows are crime categories and columns are age groups, colored by victim count. This directly encodes the relationship between two attributes in a single view, rather than requiring users to mentally combine information from separate charts. And finally, the victim sex distribution chart. Each crime category gets a bar split into proportions of female, male, and unknown victims, allowing fair comparison across crime types regardless of their frequency. The generalized selection in System C works differently to System B. You click a specific crime description in the ranking bar chart, then press Generalize. The system looks up which broader crime group that description belongs to and expands all the filters to cover the entire parent category. All 5 charts remain fully linked throughout. Across the 3 systems, the same dataset and the same analytical tasks are addressed through different design decisions: how to represent space, how to handle time, how to aggregate categories, and how to implement generalized selection. Each system makes different trade-offs, and together they illustrate how design choices shape what a user can discover. That's all for our demonstration. Thank you so much.